back and yeah, now we'll cover solar system, which is another event I um did. I'm not sure if any of the co-hosts did solar system, so I mean you can try asking them. Oh, okay. Well, yeah, you can try asking them. I guess you can still ask me if you really like, but I might be too focused on the slide, so I'm not. I probably won't be able to answer, which I'm sorry about. Anyways, let's look at these rules. So, like meteorology, solar system is another study event. So if we look at number 2 on the event parameters, we see we can also have cheat sheets, 2 sheets of paper, so 4 sides of information. And yeah, um, part 3 describes the topics, which are, um, yeah, let me do, uh, yeah, part 3 describes the topics. So yeah, this formatting is quite similar to meteorology and I'm sure to many other study events. Okay, so these are the main topics. So first in solar system, we obviously have our planets. We might need to know things about their formation or their structure, maybe some special properties about them. There's also some planetary expeditions that we might need to know. So like um, maybe an expedition that explored Jupiter or something, we might need to know about that. Yeah, we also need to know some other objects in our solar system. We have the asteroids and the asteroid belt. We have the Kuiper belt and some other things. And we also have exoplanets, and these are just planets that aren't in our solar system, so they orbit a different star. So we need to know how can we detect these exoplanets and just some similar things like similar topics to planets. And the last one, quantitative analysis. This is stuff like math and physics with calculations and numbers. So sometimes you'll be asked about some of those. So you need to know some general formulas. And yeah. Okay, let's start out with planets. So first we have Mercury. Mercury is the closest to the sun, which also means it has the lowest orbital period. The orbital period meaning how long it'll take for one full orbit. So I'll just go through the structures really quickly. So on Mercury's surface, there's a sulfur crust. There's many craters and basins from meteoroids, asteroids, those type of things. Mercury has a very thin atmosphere with these elements. And Mercury, its internal structure is very dense. And yeah, some properties, it has a Mercury out of all the planets has the highest eccentricity, which means it has the most oval shaped orbit. So like the least circular. Mercury has no moons, no rings, and yeah, it's just the smallest planet. Next, we have um, Venus. Venus is the second closest to the sun. Um, its surface, there's many volcanic plains. Its atmosphere is very thick. There's many greenhouse gases. And due to its thick atmosphere, there's a high surface pressure. And it has an iron and nickel core. And Venus, like Mercury, has no moons and no rings. It's the hottest planet despite not being the closest to the sun. And all its heat is from its thick atmosphere with all the greenhouse gases, which traps um, a lot of heat. Let me check chat. I see Ethan is quite keen and curious about these, which is nice. How do you know the structures of the planets? Well, those are from the planetary um, expeditions, not just one. Seeing many interesting comments. CO stands for carbon monoxide. Here it's carbon dioxide. There's a tiny 2 subscript. Will I talk about black holes? No, I will not, because that's not part of the thing. Okay, next we have Earth. I mean, we all know Earth pretty well, I assume. It's a third planet from the sun. We know its surface, there's many continents, there's oceans as well. Its atmosphere, which we covered in the last slides. And we know its inner core. We know like the internal structure, such as its core, its mantle, and its crust. And it also, Earth also has no rings, but it does have one moon, which I'm sure we all know. Mars is the 4th planet from the sun, and as you can see from the picture, has a very red surface, which is from iron oxidation, which just iron 3 oxide. It also has a very thin atmosphere and a core that consists of many different elements. Mars also has no rings, but it does have 2 moons, and these are called, well, it's called Phobos and Deimos. You can see those 2 on the bottom. These are the 2 smallest moons in the solar system. And yeah, the left one is Deimos, the right one is Phobos. Yeah, the red surface rust. Oh, yeah, I won't read these comments aloud, but they are quite interesting. Okay, now let's move on to the gas giants. So first we have Jupiter. Jupiter is the 5th planet from our sun. I'm sure we all know it's the biggest planet, and its atmosphere is mainly hydrogen and some helium. And we also have many storms. If you see on this picture, I'm sure you've all heard of the Great Red Spot, which is this giant anticyclonic storm. So it moves counterclockwise, and it's been there for more than 300 years. So yeah, there's no surface category because it doesn't really have a surface. Its core, we just know it's solid. It's kind of hard to study its internal structure because once you like go inside the planet, its pressure is super high. Some properties, it has 79 known moons, so there are likely many more. And yeah, so the main ones, we have Ganymede, which is the one on the left. Ganymede is the biggest moon in our solar system. In the middle, we have Io, the yellow one. Io is the most volcanically active body in our solar system. And we also, on the right, we have Europa, which other than Earth, and it has the best conditions for life in our solar system. There's like an ice layer and there's an ocean of salt water underneath. Jupiter has a faint ring system. It's not like too noticeable, I guess. And yeah, it's the biggest planet. what makes a moon a moon? So a moon is like just an object that orbits a planet. It rains diamonds there. I think it rains diamonds in Saturn, actually, which we will cover right now. So Saturn is the sixth planet from our sun. Uh, Again, like Jupiter, there's no surface, but it does have many storms. And just like Jupiter, it's hard to study the core. So some properties, it has 82 known moons, such as Titan, Enceladus, Enceladus, Iapetus. I'm not too sure about my pronunciation. And yeah, on the left, we have Titan. This is the second largest moon, and it's the only moon with an atmosphere. So that's why it's a bit like, I don't know, fuzzier, I guess. In the middle, we have Enceladus, Enceladus. It actually has the widest surface in the solar system, and it also has its own ice ring system. And on the right, we have Iapetus, which is also called the yin and yang, because one side is dark and the other side is light, just like the yin and yang. And I'm not sure if you guys can see, but there's like this little part that's like protruding from the moon. That's its giant ridge around the equator. So Saturn has a very prominent ring system, I'm sure, as you guys can see. There's many rocks and other like dust things, and they're all covered in ice. And another interesting fact, it's actually the um, least dense planet. So it's denser, I mean, less dense than water. Why are so many planets and moons named after Greek and Roman deities? Um, I think it's probably the other way around, but like many Roman gods and Greek gods are named after planets. It's probably because of their um like like because like planets, they're pretty large, so it signifies that they're probably very powerful. Okay, that's interesting. Which planet rains diamonds? I mean, I said Saturn, but someone fact checked it, and apparently it's Uranus. So yeah, and that's what we're gonna look over right now. So Uranus is the seventh planet from the sun. Um, Obviously, it doesn't have a surface. Its atmosphere, hydrogen, helium, methane, and it actually has the absolute minimum temperature, like the lowest temperature ever recorded in the solar system, which is 49 kelvins or minus 225-ish degrees Celsius. So it's really cold there. But in the inside, it has a hot liquid core. And yeah, 80% of the mass of the planet is from the core. So yeah, we can see there's an extreme contrast. So Uranus has 27 known moons, and on the left we have Titania, which is its largest moon. On the right we have Umbriel, which is the darkest moon of Uranus. It has two sets of rings. The inner rings are more faint, and the outer rings are much bigger and much more noticeable. Uh, and I'm sure you guys know Uranus, it has an extreme tilt, so it rotates almost perpendicular to its plane of orbit. It was probably hit by something. Okay, some very hilarious comments. Do all gas giants have rings? I think so. Can you collect some diamonds and sell them for money? Well, I mean, it's probably much more expensive to visit the planet, and let alone there you might not even make it back alive. Yes, I guess Uranus rotates up and down. Like, yeah. Okay, let's move on. Last but not least, we have Neptune, which is the 8th planet from the sun. Its atmosphere is similar to Uranus, but we can see there's Neptune is much more blue, and we don't know why it's much more blue. And in the picture, I think you guys can see this. There's this spot called the Great Dark Spot. This is also an anticyclonic storm. It's about the size of Earth, and yeah, it has the strongest winds ever recorded, which means there's a super high pressure. Neptune has 14 known moons. 14 known moons. Over here we have Triton. Triton's the only moon that orbits opposite to the planet's orbit around the sun, which is quite interesting. That might signify, that might suggest Triton was once an independent object. Neptune has 5 main rings and 4 less prominent ones, and it's the densest gas giant. Does Neptune have 14 moons? It has 14 like known moons. So there's likely many more that we haven't found. Why is Earth called the blue planet and not Neptune? Neptune is much more than blue. I'm not sure. Probably, yeah, I'm not too sure. There's a lot of question about diamonds. If you put a diamond in a spaceship and send it into orbit and bring it back, can you sell it as a space diamond? I'm sure you can, but I don't know how you're gonna get a spaceship. How long has the storm been going on for? I'm not sure, but it's definitely a long time. What's no moons? Did I say that? I don't know what you mean. How is Neptune a gas giant? Well, it's big and it's primarily made of gas. Are we gonna cover dwarf planets? Unfortunately not. Okay, let's just move on to some planetary expeditions. So there's obviously many of them, but I just chose these ones. First, we have Magellan. This explored Venus. It studies its volcanic surface. Yeah. Next, we have Galileo. Galileo explored Jupiter and its many moons and rings. We have Cassini, which explored Saturn, its moons and rings. And we also have Voyager 2, which explored the gas giants. It also was the first to explore Uranus and Neptune. And yeah, it also explored further than the sun's heliosphere, which is basically the sun's magnetic field. So it went past that. And yeah, on the right, it's Voyager 2. I'm getting lots of like interesting comments, like fun facts, which is quite nice. Wasn't Voyager 2 yellow? Maybe, I'm not too sure. Maybe it's just the lighting in the image. Yeah, it seems like many of you guys are very interested in this topic. Did they got on the planets? I don't know what that means. Or of or did they just
I'm
find the
pretty sure they just observed them from a distance, like kind of how our satellites work.
oh yeah. Okay, there's so many okay, I'll just answer. Will people die just touching any planets not out of Moon and Earth? Well, I mean, maybe they can survive in Mars with like proper equipment, but any other planet might be a bit hard to survive. Okay, yeah, there's many interesting comments, but let's just move on. So now let's cover some other solar system objects that aren't planets. So first we have asteroids. These are just rocks that orbit the sun, and they're mainly found in the asteroid belt, which is between Mars and Jupiter. And the main types are C-type, which chondrite, which are like clay and silicate. We have S-type, which is stony, and M-type, which is metallic. C-type is the most common. We also have meteors, meteoroids, and meteorites. And these three things, they're basically the same object. They're just in like different stages of their yeah, just in different stages. So a meteoroid is just a rock in space. A meteor is when it enters a planet's atmosphere, and a meteorite is when it reaches um, the planet's surface. We also have the Kuiper belt. I don't know if that's correct pronunciation. These are just many objects that are outside of Neptune's orbit, and one such is Arrokoth. That's the um, orangish reddish rock on the top right. We see it's like two rocks almost fused together. And we also have the Oort cloud, which is basically just a giant cloud of ice that surrounds um, the planets in the Kuiper belt. On the bottom, you can see like a basic diagram of the solar system. So we see it's not just all the planets. There's also the Kuiper belt and the Oort cloud. Yeah, it's not to scale. The Oort cloud is much larger. Next, we have exoplanets. These are just planets that don't orbit the sun, so they orbit some other, these are just some other, they orbit some other star that's not the sun. And the main types, we have gas giants, which are the size of Jupiter and Saturn. We have super Earths, which are greater or bigger than Earth, but smaller than Neptune. We have terrestrial, which are smaller than Earth, and we have Neptunian, which is the size of Uranus slash Neptune. And we also have detection, like how do we find these exoplanets? First, obviously, we have direct imaging, which we just use a large telescope. And these are, these find, like, these are better for warmer or brighter or mass, like bigger exoplanets, because you can obviously see them easier. We also have radial velocity, which is basically just observing that a star moves around in a small circle due to the mutual gravitational force between the star and the exoplanet. And these are better for bigger exoplanets since, and bigger exoplanets that are closer to the star, since it's the center of mass will be farther away from the star, so you can see it like move around more. And then we have transit. And transit is observing the periodic decrease in brightness of a star because an exoplanet is moving in front of it. So on the right, you can see transit. You see when it's the planets in position 1, you can, the brightness is at this level. And then when it's at position 3, the brightness will decrease because it's blocking some of the light. And yeah, this describes transit. Over here on the top, we have HL Tauri, which is a system of exoplanets around a young T Tauri star. Next, we have some physics laws, and this is the quantitative analysis that I was talking about. I won't go through this too much because you'll probably learn it sometime in school, but yeah. Newton's laws of motion. I'm sure you all heard of it. First law, any object that is in constant velocity, which includes being stationary, will remain in constant velocity unless there's an external force. The second law just describes the relation between force, mass, and acceleration. So we know the net force is mass times acceleration. And the third law describes action-reaction pairs, which are basically for every force has an equal and opposite reaction force. Equal means an equal magnitude, opposite means just opposite direction. We have Newton's law of universal gravitation, which is just a formula to calculate the force between two objects. So you might not notice it, but like every two objects has a mutual force between it. If you see, it's over r squared, so that means the closer the objects are, the stronger the force is, and the farther away, the weaker the force is. And then we have Kepler's laws of planetary motion, which you guys can just read. So yeah, let's do a Kahoot now. Wait. Let me post the link.
Whoever is not Andrew Yang is not me. That is true.
What is a semi-major axis? So let me just, can I, yeah, I can. So we have an ellipse, which an oval, I guess. And we see it has two axes because it's not like a circle where the radius is constant. So we have the longest one, which is the major axis, and then we have the minor axis. The semi-major axis is just the major axis divided by 2. So just this distance right there. Is this the same Kahoot? No, it's related to solar system now. Can you turn on show answer choices? I can, but I don't know how to. Should I turn it? It's already turned on. Should I turn it off or?
Keep it on. It's more efficient that way.
Okay. Yeah, let's just start right now. Oh, wait, let me clear my annotation. Which planet is the farthest away from the sun? Yep, it's Neptune. Andrew.
I'm not in the game. Whoever is Andrew Yang, you're really funny.
Double points. What body is this? There will be an image eyes. This one might be a bit harder. So
Props to you if you get this one.
Io. Yeah. It's the yellow moon. Yeah. Double points. I don't. What is this thing? Oh, yeah, good job. Which planet does this moon belong to? Give you a hint, this is Iapetus. You can see from the bridge, there's also the yin and yang moon. Yeah. Good job, everybody. It was a very great name. in fifth place. Other than Earth, what body has the best conditions for life? See some people typing the answer to me in chat. Good job, but yeah. Yeah, it was Europa, which is a moon. I think there's Jupiter and has like an icy surface, but a giant saltwater ocean. Good job, everybody. Which planet has an extreme axial tilt? Yep, Uranus. Almost perpendicular to its plane of orbit. Good job. How many known moons does Jupiter have? So obviously there's many unknown moons that we probably haven't seen yet, but how many known ones? Yep, 79. Which planet has the most eccentric orbit, or the least circular orbit? Yep, Mercury. Which best describes the transit method of exoplanet detection? Mm-hmm. Okay, yeah. So this one obviously is green because that's the correct answer. Red, this is direct imaging, which is using a large and powerful telescope. Yellow is um, radial velocity, observing a star's wobble from an exoplanet's gravity. And blue, observing how light from a star bends due to an exoplanet's gravity. That one I didn't cover, but it's called gravitational microlensing. So yeah, green is the correct answer. Okay. Also, it's 5:30, so if you guys have to leave, you can leave, or you can continue the Kahoot. There's 6 more questions. Double points. What is this object? Yep, it's Arrokoth. Which one of these space missions involved the exploration of Venus? Magellan. Cassini was Saturn, Galileo was Jupiter, and Voyager 2 was the Jupiter, Saturn, Uranus, Neptune. Good job, everybody. If there were a giant lake of pure water, which planet would be able to float?
And by giant, Samuel means like really, really, really giant.
It's Saturn. So if something would be able to float, it has to be less dense than water. And obviously it can't be Mercury because Mercury is basically a rock. So then yeah, Saturn's the least dense gas giant. So yeah. Good job. What type of exoplanet is bigger than Earth but smaller than Neptune? Yep, a super Earth. Good job. Penultimate question. What is the name of the largest known moon? Yep, it's Ganymede. Okay, last question. Good luck to everybody. Multi-select. Which terrestrial planets do not have moons? Yep, it's Mercury and Venus. Earth, we all know, has a moon, and Mars has Phobos and Deimos. So yeah. Let's see who the results. 13 out of 15. A fat pig. That's a pretty good score. Adrian. 15 out of 15. That's very impressive. Justin. So yeah, good job, and good job to 23 times 3 in Madison. So yeah, I think that's basically